Hello everyone, today we will learn the concept of functions together. In junior high school, we have already learned the concept of functions and understand that functions are mathematical models and tools for characterizing the correspondence between variables. Can you talk about the definition of functions in our junior high school? If there are two variables x and y, and for each definite value of x, y has a unique definite value corresponding to it, we say x is the independent variable and y is a function of x. With this definition, let's take a look at two small questions. First, what is the correspondence between the circumference L and the side length x of a square? To express it as a function, L equals for x. Is this function the same as the proportional function y equal to for x? Is y equal to x and y equal to x divided by x squared the same function? Perhaps everyone has the answer in their minds, but how can we explain it? If we use the definition of junior high school to explain, it doesn't seem sufficient. So, in order to solve such problems, we need to further study the definition of functions. Firstly, let's take a look at a few practical issues. Question 1. If the Fuxing high-speed train accelerates to 350 km per hour and maintains a constant speed for half an hour, how is the relationship between the distance as traveled by the train and the running time t during this half-hour period expressed? The uniform linear motion s should be equal to the speed multiplied by time, so s is equal to 350t. Is this a function? Why? Since we have already learned functions in junior high school, how can we make judgments? So, what do we know about this problem? It can be explained that for any time t, there is a unique and definite distance s corresponding to it. Therefore, s is a function of t. Next, someone said that after accelerating to 350 km per hour, this train moved 350 kilometers in just 1 hour. Do you think this statement is correct? Many people have already agreed. In particular, I would like to ask those students who think it is correct, do you know the speed of a train running for 1 hour? The question only tells us that we should run at a constant speed for half an hour, and our time t has a range. If explained according to inequality, t should be greater than or equal to 0 and less than or equal to 0.5. We are now accustomed to expressing how to measure a range in the form of a set. Okay, then on the basis of junior high school knowledge, how do you think we can express the correspondence between s and t more accurately? This presentation is based on the understanding of middle school. For any time t, there should be a range at any time. Let's consider a set of 1. A 1 is equal to t, greater than or equal to 0, and less than or equal to 0.5, all of which have a unique and definite distance s. S is not all real numbers and should also have a range. We say that in the set B1 equal to 0 and less than or equal to s and less than or equal to 175, there is a unique and definite distance s corresponding to it. If we make such changes, we will find that the range of this variable s and t will be very precise. This changes the correspondence between variables t and s in junior high school to a correspondence between two sets, the correspondence between sets A1 and B1. If we use symbolic language to represent this correspondence, s should be equal to 350t. The set of independent variables is a 1 equal to 0 less than or equal to t less than or equal to 0.5. The set of function values is b1 equal to 0 less than or equal to s less than or equal to 175. This is an expression of symbolic language. If expressed in words, we should rephrase it like this: for any time t in set A1, according to the corresponding relationship s equals 350t, there is a uniquely determined distance s in set B1 that corresponds to it. The second question. A certain electrical maintenance company requires workers to work at least 1 day per week and no more than 6 days per week. If the company determines a salary standard of 350 yuans per person per day and pay the salary once a week, so how do you think a worker's weekly salary should be determined? If we use the letter W to represent salary and D to represent days, we can see that the correspondence between W and D should be like this: W is equal to 350D. Is a worker's salary W a function of their number of working days D? Still using the definition of junior high school to judge it. For any working day D, there is a unique and definite salary W corresponding to it. So W is a function of D. We will imitate the statement in question 1 and provide an accurate representation of the correspondence between W and D in this question. Let's recall that we just made two forms of representation. Firstly, there is symbolic language. Clearly define the correspondence between the set of independent variables and the set of function values. The corresponding relationship is that the set of independent variables with w equal to 350d is counted as a 2. A 2 is selected from days 1 to 6, and we use the enumeration method of sets to represent it. Similarly, the enumeration method can be used to place the 6 values of b2 in curly braces. From a linguistic perspective, for any working day d in set A2, according to the corresponding relationship, w is equal to 350d. In set B2, there is a uniquely determined salary w that corresponds to it. We found that the functions in question 1 and question 2 have the same correspondence. Question 1 states that s equals 350t, while question 2 states that w equals 350d. Do you think they are the same function? Why? We can see that these two functions have only changed the letters in terms of correspondence, and there is not much difference. But we need to consider two other things. One is the range of values for the independent variable, and the other is the range of values for the function, or what we call the set of independent variables and the set of functions are not the same, so they are not the same function. So what do you think are the elements that affect the function? Firstly, it is not only important to pay attention to the correspondence relationship, but also to the set of independent variables and the set of function values, which are the three elements that affect the function. Please remember it. The quality of air in a city can be measured by the air quality index. The air quality in Beijing has been very good in recent years, and you can often see blue skies and white clouds. So what was the situation in the past few years? Figure 3.1.1 shows the variation of air quality index in Beijing on November 23, 2016. In this graph, our horizontal axis can represent time t. The vertical axis can represent the air quality index AQI, abbreviated as letter I. So how to find the AQI value I for 12 hours at noon based on the graph? From this chart, it can be seen that most of the air in Beijing is concentrated in green areas, which is still very good. Between 8 and 12 o'clock, there was mild pollution. The smaller the I value of the air quality index, the better the air quality. So if you want to find the I value at 12 noon, you can look at the position of 12 o'clock on the horizontal axis. We can see that its area should be in the yellow zone. What is its I value? Can you read it? Some people say it looks like 75, while others say it looks like 80, both of which make sense. So, if I have to say something else, can you also agree? Does this mean that the I value at 12 noon is not unique? We know that the method we use to find this I value is by observing it with the naked eye, by looking at a picture. This graph is our correspondence, so there may be errors, but it still cannot change the uniqueness of the I value at 12 noon. Do you think I here is a function of t? We still use the judgment criteria of junior high school. For any time t, there is a unique and definite value of I corresponding to it, so I is a function of t. Can you describe the correspondence between I and t using the same method as before? From the perspective of symbolic language, its corresponding relationship is a graph, namely figure 3.1-1. The set of independent variables is from 0 to 24, and all times can be taken. We use the set description method to represent it. That is, the set of 3 is equal to 0 and less than or equal to t and less than or equal to 24. Who is the set of function values? From the image, it appears that the maximum and minimum values of the function value I are not provided. Can we write B3 is equal to I less than 0 and greater than 125? Some students may think that taking 125 is inappropriate, so is it appropriate for me to write it as less than 130? I can't be sure either. It can be seen that the set of function values at this time cannot be represented at all. What should I do? Let's take a larger set. Let's take the set B3, which is equal to 0 but less than I and less than 150. That's definitely not wrong. At this point, our set of function values is no longer B3. There are many redundant elements in B3, which we call the set of function values. At this point, the set of function values should be a subset of the set B3 where the function values are located. We may refer to the set of function values as C3. C3 is included in B3. Below we will present it in written language. For any time t in set A3, according to the correspondence shown in figure 3.1.1, there is a unique and definite value I corresponding to it in set B3. Now let's take a look at the last question. The Engel coefficient R is commonly used internationally to reflect the quality of life of people in a region. The lower the Engel coefficient, the higher the quality of life. Table 3.1-1 shows the changes in Engel coefficient of urban residents in a certain province of China, indicating that the quality of life for urban residents in the province is getting higher and higher. Do you think the Engel coefficient are given in Table 3.1-1 is a function of year Y? Why? Let's explain it from the definition of junior high school. Because for any year Y, there is a unique and definite coefficient R corresponding to it. So we say that they form a functional relationship. So what is the corresponding relationship? We previously introduced the correspondence between parsing expressions. Introduced the correspondence between image representations. We use a table to represent the corresponding relationship for this question. The corresponding relationship is shown in Table 3.1.1. Can you refer to the previous method to provide an accurate characterization? There are still three things. The first thing about correspondence is the table. The set of independent variable values is presented as set of 4 in the form of enumeration for all 10 years in the first row of the table. The second row of 10 elements in the expression is also presented as set B4 of function values in the form of enumeration. Understand from the perspective of textual description. For any year Y in set of 4, follow the corresponding relationship set in Table 3.1.1. In set B4, there is a unique and definite coefficient corresponding to it. So do you think it's okay to write the fourth set of numbers in descriptive form, where 0 is less than R and less than or equal to 1? According to the definition of Engel coefficient R, we know that Engel coefficient R should indeed belong to such a range. So, if written in the form of enumeration, it represents a set of function values in which all elements are presented. If written as B4 using the descriptive method, it represents the set of function values, with the former being a subset of the latter. The functions in the previous 4 questions still have many common characteristics. Let's take a look. In the previous question, these keywords, corresponding relationships, sets of independent variables, sets of function values, and sets of function values were mentioned. Firstly, let's take a look at the corresponding relationship. The correspondence between questions 1 and 2 is in the form of an analytical expression. Question 3 is the form of the image. Question 4 is the format of the table. Regardless of the form, they can all be unified into a symbol called correspondence relationship F. The set of independent variables A1, A2, A3, A4 can be abstracted into a set of numbers A. The set of function values B1, B2, B3, B4, we can also abstract it into set B. So from this, we can conclude that the definition of a function in high school should be described as follows. Assuming AB is a non-empty set of numbers, if for any number x in set A, according to a certain determined correspondence relationship F, there is a uniquely determined number y in set B that corresponds to it. So we call f A to be a function of set A to set B. The new definition also has a new notation, which we refer to as y equals fx and x belongs to set A. Among them, x is called the independent variable. The range of x values A that we often talk about is called the domain of the function. The y value corresponding to the x value is still called the function value. The object of description for a set of function values is fx. The language used for description is x, which belongs to domain A and is called the range of function values. So, if we use our own habitual way of expression, the description object is y, which is equal to fx. X belongs to the domain A. Therefore, both forms can be used to represent the value range of the function. Why isn't the value range the same as the domain? The domain is set A. Why isn't the value domain set B? We recall the two concepts discussed in questions 3 and 4 earlier. The set of function values and the set of function values are different. The value range corresponds to the set of functions. It should be a subset of the set where the function values are located. That is to say, the range of values is a subset of set B. With new definitions, we also have new expressions for the 3 elements of a function correspondence relationship. We use the letter F, which is called correspondence relationship F. The range of values for the independent variable is called the domain. The range of values for a function is called the range of values. If you were asked to redefine linear, quadratic, and inverse functions using the definition of a function, how would you express this function? Due to the three elements of a function, we can consider the domain and range of a linear function as a set R. The corresponding relationship is that y equals x plus b. The domain of a quadratic function is R, and its value range needs to be determined based on the size and sign of a. When a is greater than 0, the range of values is y greater than or equal to 4ac 4a minus the square of b. When a is less than 0, y is less than or equal to 4ac of 4a minus the square of b. The corresponding relationship is y equals x squared plus bx plus c. There are requirements for the domain of inverse proportional functions. It should be x0 and x belongs to R. The range of values is y0 and y belongs to R. The corresponding relationship is also its analytical expression. Can you construct a problem scenario where the variable relationships are expressed using the analytical formula y equals x multiplied by 10 minus x? We can easily think of building a rectangle with a circumference of 20. One of the edges is denoted as x and the other edge is 10x, so y at this time represents the area of the rectangle. To explain from three elements, the domain is defined as 0 less than x less than 10, which we refer to as set A. As the value domain is a quadratic function, its graph opens downwards, so it has a maximum value. B should be 0 less than y less than or equal to 25. Corresponding relationship F, so that set A corresponds to B, and the side length x of the rectangle corresponds to its area x multiplied by 10 minus x. Now let's return to the initial question. We cannot explain this problem with the help of function definitions from junior high school. After learning today's content, we can see the relationship between the circumference L and the side length x of a square. Is L equal to 4x proportional and y equal to 4x? Obviously not. Their two domains of definition are different, and their value ranges are also different, only their corresponding relationships are the same. The function y equal to x and y equal to x divided by x squared are not the same function. Just having the same correspondence, the range of localized values is different. So after finishing high school knowledge, let's have a review and summary. Compared to the concept of functions learned in junior high school, what new understanding do you have about functions? Both middle school and high school functions have a commonality in describing the relationship between two variables x and y. The difference is that in middle school, it refers to the correspondence between variables, while in high school, we change it to the correspondence between sets. In order to accurately determine the range of values for two variables x and y, and to provide a more precise description of this problem, if we combine the study of function concepts, can we talk about how to establish mathematical concepts? Firstly, we have observed that many specific problems share common characteristics. We use mathematical concepts to abstract these common features, continuing to provide a representation of this new concept. For example, if a function has a new representation where y equals fx and x belongs to a, this will enable the widespread application of these concepts to various disciplines. So the problem scenario we just constructed is an application of a concept.